You installed that level there. Okay.
Miss Saima Sheikh. Ma'am, good morning. Hello.
Good
Ma'am,
morning,
good morning.
Manoj ji. Good morning.
Ma'am, how are you, ma'am?
Fine. कैसे हैं आप?
Ma'am, बहुत ही बढ़िया.
अच्छा.
Can we start the meeting by the time the participants will keep on joining?
कर सकते.
Okay, ma'am. So to all the participants and to the speaker, Dr. Shama Gupta, very good morning and welcome to the first session of day 5. Dr. Shama Gupta started her professional career with Regional Remote Sensing Center, ISRO Dehradun in the year 2001, and she is currently working as scientist in Indian Institute of Remote Sensing, ISRO Dehradun. Her research interests include urban climate and microclimate, urban green spaces, 3D modeling of urban areas, and application of geospatial technologies in urban planning. She has executed a number of research and operational projects on remote sensing applications. She has more than 60 publications on her name as research papers in international and national journals of repute and conferences and ISRO technical reports. Dr. Gupta completed her PhD in architecture and planning from IIT Roorkee on urban climate. She completed her master's degree in urban planning from SPA Delhi and bachelor's from MNIT Jaipur. Welcome, ma'am. Welcome to the first day session. So thank you very much, ma'am. She has executed.
Yeah, thank you, Manoj ji. Thank you for inviting me. So let me share my screen. Am I like and let me. So is my screen visible?
Yes, ma'am, it's visible, ma'am. You can do the full screen.
Am I audible?
Ma'am, full screen is not visible.
Full screen is not visible. I have not kept it into slideshow. Now it is visible.
No, ma'am.
Okay. Let us wait maybe 2 minutes. It may be taking. Otherwise, I'll stop and share again.
Ma'am, the issue maybe you might have shared the PPT only. Yes, ma'am. Now it's full screen, ma'am.
Full screen is visible. So
yes,
okay.
ma'am. Yes, ma'am.
So first of all, I thank Dr. Manoj for inviting me. And today's topic is geospatial driven research and modeling for heat waves and urban microclimate studies. So one second. Okay, I'll put it into this. Yeah, okay. I think some issue with the video. I'll just switch off the video. I put it off. Okay. So, okay, let me start with this deliberation. So we know that urban climate is has its own distinct climate. Like urban areas generally are generally warmer than their surroundings. So there are more 4 major parameters which has an impact on urban climate. One is your height of roughness feature, like how, see, because buildings, they act as roughness elements. So if a building is very high rise, building is mid rise or low rise, so how it affects your even trapping of heat, shading, as well as it affects the wind flow in urban area. Similarly, your vegetation also, whether it trees, wood, bush, grass, soil, it will has impact on your climatic, like microclimate aspect. Like, so it is, local climate is totally affected by all these parameters. Now, second component is your packing of roughness features. Packing of roughness features is like whether it is compact, it is open, sparse. So how much area is like covered? What is the density of your roughness feature? That also has an impact on your urban climate. Now, if we have surface cover, what kind of surface cover is there? It is impervious, pervious, or like it is low plants or soil or trees. So all these has an impact on your urban climate. And other thing is your thermal admittance of materials, whether it is heavy materials like concrete or stone, or it is lightweight material like sheet metal, wood, and so on. So all these materials. So there are, like, I'll talk about like how remote sensing can help. So there are four aspects of urban, which is like they have very much impact on your this urban microclimate. First is your urban structure. Urban structure means permeability. How much is the permeability of area? So in urban area, we know there is a lot of increase, like there is a significant increase in impervious surfaces. So there are surface cover fractions. In surface cover fractions, we'll discuss in detail. But here we have lot of host of 2D remote sensing data. Like you have uh, I have earlier also discussed like 0.3 to 1 kilometer data is available. So at what scale you want to do the study, that is depending upon, you have to choose your satellite data. So mostly we use 1 meter or better than 2 meter or 5 meter, 5 meter and better that resolution data for these kind of studies. So we can easily judge your surface cover fraction, or we use sometimes the medium resolution data just for surface cover fraction, like your Landsat. If we are looking at with the comparison between two cities, if we are looking at regional scale, then we have to use maybe 500 meter or 1 kilometer resolution data. So depending upon which scale we are doing the study, we have to have this surface. We can easily get the information on surface cover fraction. Now, second aspect of urban is urban geometry, like 3D geometry of urban area. And that is defined by different, that is known as urban canopy parameters, like building height, sky view factor, height width ratio. For this, we need 3D information. Like what is the height of the building? Based on your height, it will be, and spacing between the building height width ratio will be computed, or your sky view factor. So for this, we need 3D information, and that is obtainable from LIDAR, your interferometric SAR data. LIDAR is your light detection and ranging, aerial photographs, or you can even obtain this information from very high resolution optical stereo data. Now, what is a very high resolution optical stereo data? It is nothing but two overlapped satellite images. They can be taken at a different point of time or same time. Same time is better, but depending, they fulfill some condition, and those conditions you need to go into photogrammetry for detail. But that is like overlapped photographs with the good V by H ratio and parallax. So these optical stereo data can be utilized. Now there is urban fabric. Urban fabric is like material. Material is mostly concrete, asphalt, but you can have like clay tiles also. So generally, the generally used remote sensing data, that is multispectral data, it cannot resolve between urban materials. So for that, we need hyperspectral sensors. But unfortunately, in today's context, we don't have very high resolution hyperspectral sensors. We have Hyperion sensor, which is freely available, but that Hyperion sensor we can go up to like only up to land cover, like distinguish between the built up and urban area. Just a second. So hyperspectral sensors, they are very good in that sense of like you can distinguish all urban materials. Now comes your urban metabolism. Urban metabolism is your anthropogenic heat. So this anthropogenic heat, you can use thermal remote sensing data to compute your anthropogenic heat. So this is how your remote sensing data is different. And now one by one, we'll discuss how it can be utilized. So first aspect is your urban structure or permeability. So there are three types of urban surface fraction as per Stewart and OK. That is your pervious surface fraction, impervious surface fraction, and building surface fraction. So this is basically pervious surface fraction. is the total pervious surfaces, including your vegetation, soil, bare soil, your water, all these come under your pervious surface fraction. And impervious surface fraction is basically your road, paved surfaces, bare rock. It is different than your building surface fraction, because fraction of this is, it also include your bare rock. Building surface fraction is basically all the buildings, so it include only buildings. So this information you can easily segregate using your remote sensing data. And this here you can see that this is the image of Chandigarh, where this pervious surface fraction has been computed. So here one grid size has been chosen, and this pervious surface fraction, how it is changing, that has been. So you can see that it is very low within the city area, in some part of the city area, but it's in the surrounding, it is high. Now this this we can even easily correlate your urban surface fraction, like in this, with the land surface temperature. Now this land surface temperature can be obtained using your thermal remote sensing data. So we can see that this is a pervious surface fraction, and this is your land surface temperature. So you can see that there is a very strong negative correlation between your land surface temperature and pervious surface fraction. As your pervious surface fraction increases, your temperature decreases. Similarly, if you want to look at between the difference between different land use, land cover, so you can see water has the lowest temperature, but in bare soil has the highest temperature, because satellite passes at 10:30. Suppose this analysis you do during night, so maybe built up will give you the highest temperature. And this is building surface fraction. So here also you can see how it's a variation in different season. And you can see as the building surface fraction is increasing, it is your temperature is also increasing. It shows a positive correlation. But here it is showing a binomial relationship, not very linear relationship, because in winters you can see that whenever your building surface fraction increases, there is a because of low elevation of sun, there is a effect of shading is more prominent in winter season. So that creates the scenario where when the building surface fraction increases, it because of shading at generally 10:30 to 11 is the satellite pass. At that time, your temperature is less in high building fraction area. Similarly, here also you can see the similar pattern of pervious surface fraction, where it is showing negative correlation in all the seasons. Now, this is the first part of urban climate. This is like urban structure. Now, second comes your 3D geometry. 3D geometry is basically this is your surface fraction, but there are different parameters like complete aspect ratio, which is addition of your wall area, your plan area, and your ground area, and divided by your this total area. Similarly, this is the building surface area to plan area ratio. This is mean building height. Then sky view factor. Sky view factor is how much sky is visible, and that is spherical sky. Like here you can see what is the sky visible when you are standing in a canyon. So this is and there is like you have frontal area index, like when you in particular wind direction, you have height width ratio, then your frontal area density, plan area density, roof area density, and so many different urban canopy parameters. So I'll give you one example here that this is an ortho image, and we have got one NDSM of or DSM of this area, because this is very high resolution optical stereo. So using that high resolution DSM, we could measure the building height, and this is the mean building height, and this is the building footprint from the satellite data. And we can compute other factors also, like sky view factor, your building volume. So sky view factor has been even validated using ground data, and we have found almost 99% correlation with observed data that we had observed using ground data, using fisheye lens. and computed using your satellite data, and we have found nearly 99% correlation. So if you look at the sky view factor versus LST, then you can see that this kind of phenomena is seen. Like you can see that whenever it is increasing, so at one point it is temperature is decreasing, but after a point it increases. So maybe there is a lot more studies has to be done in this area, because then we can maybe prepare some urban design guidelines, like this kind of sky view factor should be maintained in street canyons. And this is like you can see with the building height. So you can see that it is not showing linear relationship because of, again, seasonal, based on the season. You have a shading phenomena whenever there is a building height is there, and what is the width of your canyon, that also dependent on that. Another one factor was that like LSP is more of like it captures your 2D temperature, but not the 3D temperature. For 3D temperature, definitely you need to do a modeling. So modeling will help you to get the 3D temperature. Now, if we talk about urban fabric, that is like composition of materials. So I have already discussed that there is availability of data is questioned. In some of the countries, there is airborne data is available. But in India, we have restriction on uses of it, and it's very limited data is available. And Hyperion Prisma, they have 30-meter resolution, which is inadequate to resolve within urban, like to resolve the different buildings in urban area. Now, fourth aspect is your urban metabolism. That is your anthropogenic heat flux. So anthropogenic heat flux, basically for natural land surface, it is defined as sensible heat flux, your ground heat flux, and your, latent heat flux, ground heat flux, and sensible heat flux. But for urban surface energy balance, your anthropogenic heat flux is added to the equation of this side of your equation. So this is basically how you can easily utilize your, like this is one example of Delhi, where this net radiation has been computed using satellite data. And after this ground heat flux, then your latent heat flux and sensible heat flux, and that it helps us to even compute your anthropogenic heat flux. So there is a lot of equations you have to follow step by step, and then you can compute this anthropogenic heat flux. Now, we'll talk about one very important phenomena that is very well widely discussed and widely known phenomena, that is urban heat island. Means your urban areas is warmer than your surrounding non-urban region. And this is like all over world, there is lot of literature is available in this aspect. So here you can see that how it behaves, like whenever there is a dense urban area, the temperature goes up. And if there is more of vegetation, then temperature goes down. Now, if you see that urban heat island also has a phenomena, it is a phenomena which is not static phenomena. It is very dynamic phenomena, depends upon your time of imagery, your day, like time of measurement. So it has a very much of diurnal, hourly, hourly variation, it has diurnal variation, it has seasonal, and it is annual variation. So even day and night variation are also very strong. Here you can see that in this surface temperature during daytime, air temperature and surface temperature has lot of difference during daytime. But if nighttime, your surface temperature and air temperature doesn't have much of the difference. So that is what the phenomena has been seen. And again, the phenomena is same, like wherever the dense packing of built material is there, then you have the higher temperature in these areas. And even industrial also has higher temperature than your other areas. So if we talk about this area, like albedo of urban material means because urban materials are generally low albedo, so they absorb a lot of heat given by sun, and this heat is generally because of their thermal capacity is also high, so they keep on absorbing the material, and they sometimes they release that in the night time. So that is what mostly, that's why urban heat island phenomena is quite prominent during nighttime. Then there is a reduced vegetation. There is anthropogenic heat due to transportation, heating, cooling, and so many other activities. There are urban geometry, like your 3D geometry of urban area, then weather and geography. So all they have an impact on your urban heat island formation and its pattern and its profile. So now, why we should worry about urban heat island phenomena? That question may come to someone's mind because, okay, this is there, it is there. Okay, fine. We have so many means, like we have air conditioning, we have so many means, like we can fight with that. But now, why we should worry about it? Because if we talk about urban heat island, that major impacts. One is your increased energy consumption. Like you can see that there is a huge like as your temperature increases, there is a huge demand of energy, and once you are generating energy, then there is definitely there is a lot of fuel consumption for generating the energy also, and that increase your carbon budget. Now another, your heat related mortality and morbidity. So when your heat urban heat island in phenomena, like basically you can say if there is a heat wave phenomena also, urban areas are more impacted because urban area has already existing urban heat island phenomena. So they have more heat trapped into their area, and that create lot of, and most vulnerable are your elderly and children population. Then comes your air, elevated emission of air pollutant and greenhouse gases. See, there are studies which shows as your temperature increases, there is an increase in the concentration of ground level ozone. And this ground level ozone leads to a lot many respiratory problems in especially the vulnerable population. So this is a major source of, like there is a lot of respiratory issues like asthma and other health related aspects. So that is also one aspect. Now there is effect on water quality also. See, because of like whatever the heat is captured by the urban area, impervious surfaces, that is also transferred to your subsurface also. So that has an impact on your water quality. And when the temperature of the water increases, it becomes more acidic, and it is like difficult for some aquatic life to sometimes, like there is a change in your configuration or composition of your aquatic life because of that. Now, if we talk about urban heat island also, urban heat island also has a different phenomenon. It is different kind of urban heat island phenomena is present at different level of, different vertical level of your urban canyon. Like when we talk about surface urban heat island, when it is like temperature sensor, like surface temperature of your surface, then it is basically measurement is done is temperature sensors attached to surface, and it is generally studied using thermal remote sensing satellites, aerial or UAV, and basically your land surface temperature is used to study this surface urban heat island phenomena, and this is widely used area of remote sensing where this has been studied. Now another comes your canopy layer urban heat island, where you need to have, it is basically canopy layer is screen temperature or generally taken as 2 meter or 10 meter height of urban area. Most common is your 2 meter height from the ground. And this can be studied using your temperature sensors at fixed station, like you have a network of stations, or you can take it as mobile towers. Like the common, though these are the most common method to study urban layer, canopy layer urban heat island. That is temperature sensors, either a very good network of temperature sensors, or you take a mobile towers across urban area. The temperature sensor has one disadvantage, that their spatial resolution is not very good, because it is very difficult to install so many temperature sensors in urban area. So their spatial resolution is generally poor, but their temporal resolution is very good. But if we talk about mobile towers, then you take a towers on maybe you fix your temperature sensors at one vehicle, and you take a towers along around your city. So it has very good spatial resolution, but sometimes the temporal resolution is compromised. For remote sensing, like you have mini SODAR or mini LIDAR kind of instruments. And another comes your urban boundary layer heat island, with the heat island which is present at boundary layer height. So this is temperature sensor mounted on aircraft, balloons, and tall towers are used to study this, or maybe sometimes the profilers. Of subsurface heat island, that is local, and this is very less studied heat island because you need a temperature sensor within the substrate. So let us talk about the surface urban heat island, because that is the most widely used area of your remote sensing. So that is like as for there is a series of data sets are available, like Landsat is there, where you have the thermal earlier TM, ETM, and now thermal infrared remote sensing sensors are there. And it gives you the data at 30-meter resolution, although thermal data is captured at 100-meter, but they resample and they give it to you at 30-meter. Now, another satellite which is widely used is MODIS, which gives you 1 kilometer LST is available. Your product is available for day and night. It gives you 4 passes, like 2 in the daytime and 2 in the nighttime. One is 10:30 and 1:30 in the daytime, and one is 10:30 and 11:30 in the night. So all these passes are available, and they provide you through Google Earth Explorer. You can get 1 kilometer LST ready-made product for study. But since it is 1 kilometer, so definitely it can be used for your regional level analysis. So I'll give you some example how it can be used. Then there is a EcoStress satellite, and there is a SNPP and JPSS. There are different satellites, NOAA, AVHR, AVHRR, GEOS, this is geostationary satellite. This gives you 10-minute image update, but it is coarse resolution. Similarly, Sentinel is also there, but it also gives you a coarse resolution data. And there is a Sentinel is multispectral data. So it provides you 10:30 AM PM path, but it doesn't provide you thermal data. It provides you multispectral data. So all these sensors are available, and you can look at the spectral bands and mostly use your Landsat TM and MODIS, Esther. So these are the most used satellite data sets, and out of this Landsat and MODIS is the maximum used satellite data. So here you can see that it is giving you 100-meter thermal data. MODIS is giving you 1 kilometer, Esther is giving you 90-meter, and then you have VIRS and AVHRR. So most of them are giving you very coarse resolution data, but Landsat is which is giving you 30-meter data. But temporal resolution is again one question. In MODIS, the temporal resolution is good, but spatial resolution is poor. So this is one of the because you can say one of the gap in remote sensing data. So even there is a talk or there is a discussion about filling up this gap, because you have big temporal resolution, then sometimes your spatial resolution is compromised. So how to overcome that aspect? So now we'll talk about this retrieving LST. There are different algorithms, your single channel, then mono window algorithm, then split window algorithm. So here you can see that for Chandigarh area, Chandigarh region, this algorithm has been, single channel algorithm has been used for October 2008 data. And this land surface temperature has been retrieved. Similarly, for October 2015, using split window method, the land surface temperature has been retrieved. So you can see that this is October 2008 land surface temperature of Chandigarh region, where you can see the temperature range is from 22 to 30 degrees centigrade. But when we assess the October 2015, although we have taken the anniversary dates, the dates are almost nearby only. So then we can see that there is temperature, lower temperature has gone further lower, but the higher temperature is gone quite high, like from 30 to 37 degrees. So you can see this is a significant jump. So similarly, there is an example of land surface temperature for Delhi in different seasons. So you can see that in summer season, this is the phenomena. So here you can see because of the availability of bare soil, your urban area is showing comparatively lesser temperature as compared to surrounding. And similarly, but if you see at the monsoon, because there is a vegetation area is quite has lot of moisture. So monsoon, your urban area is showing more temperature than your surrounding. Even due to post monsoon, again your heating phenomena of your surrounding like bare soil is there. And even winter is your shading also plays a role in urban area, because at the time till the time of past, like because of shading, there is a less heating of urban area. They keep on absorbing and emission takes place later. So that is kind of phenomena is visible. So when we see the spatio-seasonal variability of surface urban heat island intensity, we can see like this is a building surface fraction. So we can see in different season the kind of phenomena. So here also in this winter phenomena is seen. And then pervious surface fraction, there is a like that it shows a negative correlation, and the impervious surface fraction is generally shows a positive correlation with your land surface temperature, and building height shows a non-linear relationship with your land surface temperature. So once we talk about this land surface temperature data, so you can see that it is data acquisition time of land surface temperature data. It generally don't coincide with the maximum urban heat island. So like if you see sometimes not, this is most of the time it happens, like if you talk about the arid zone area, there nighttime UHI is more prominent, but your sometimes your data set is available at 10:30 to 11 a.m. and that time it is not your, it doesn't coincide with maximum urban heat island phenomena. But it also don't provide you diurnal profile. Like it widely used data is Landsat, which provide you the daytime pass. So that is very difficult to obtain. Like you have only daytime system. Now there are cloud cover. So they see like for Delhi, we have done this seasonal exercise, and we could find only 6 or 7 scenes in the whole year because of cloud cover. Sometimes there is a cloud cover, sometimes there is a fog, sometimes there is a haze. So all these issues, like the data which can be utilizes, that we could find only 6 to 7 scenes in a year. So it decreases your data utility. Now, there is a question of obtaining high spectral, spatial, and temporal resolution with the same instrument that I had already discussed, that like Landsat has a very good spatial resolution, but it doesn't have very high temporal resolution. Similarly, MODIS has high temporal resolution, but your spatial resolution is compromised on that aspect. So all these issues are there with the satellite remote sensing data. Although this is one of the data which provide you very good spatial uh, distribution of land surface temperature, which is not even, which is very difficult to obtain using your ground-based observations. So this is very widely used data. Now, in this case, we have to go for the modeling. I had earlier also told that modeling also is one of the aspect where we can utilize this we can have the land surface temperature or surface heat island studies. So in this study, I am going to show you that one study which we have done, that WRF urban model has been utilized for in Delhi urban area and for UHI studies. So we have taken some that satellite data, which is used for preparing the 3-class urban ULULC, which has been integrated in WRF model. And there are high resolution land surface parameter which has been downloaded from internet. NCEP GFS, like global forecast system, that data that provides you initial and boundary condition, and it has been downscaled to 500-meter resolution. Using ground observation, this WRF output has been validated using MODIS LST and ground observation. And 3-season simulation for 3 days has been done: summer, monsoon, and winter. We could do only 3 seasons because of the limited computational resources, but if the computational resources are good, we can go for more number days or more number of time, we can go for simulation. Now here, using this area, another one one very important aspect of your modeling, like numerical weather prediction models, which can be utilized for this WRF model, that is your nested domain. You can create the outer domain to cater to address the regional phenomena. So impact of regional phenomena is also taken into account. When we go for physical modeling or very high resolution modeling, sometimes that is missing, that you have only the area and you work on only area. But in this WRF model, you have the nested domains. So this is your outer domain, gives you 1.5 kilometer domain. It gives you that regional level phenomena, and this local level phenomena can be modeled into the inner domain, that is 0.5 kilometer domain. Now in this area, if you see that Delhi is surrounded by agricultural cropland, and this composition of which changes with season. So every season you have a different kind of phenomena. So you can see that list 4, resource set to list 4, there is one methodology is developed to prepare the 3-class urban LULC, where is like low intensity residential, high intensity residential, and industrial, commercial, and transportation. So this data has been utilized, and percentage of area has been covered by each class, low intensity and high intensity, and industrial, commercial, and transport layer was digitized and overlaid over it. So you can see that it's very detailed urban land use which has been prepared. And now we have carried out different simulations, where you can see first simulation where we have taken default in model, default land use land cover, and we have taken even default land surface parameter. Land surface parameter means your albedo, your elevation, your vegetation fraction, your photosynthetically active radiation, and many other parameters. So all these this land surface parameter was also kept as it is, whatever was available in model. Now in second simulation, LULC was updated, like what I have shown you in the previous slide, the 3-class urban LULC, but land surface parameter was kept as default. But in simulation 3, LULC was kept as default and land surface parameter was updated. And in simulation 4, LULC was also updated and land surface parameter was also updated. So you can see in all the parameters like pressure, wind speed, temperature, you can see there is a significant reduction in your different this RMSE value as with the updated LULC and updated land surface parameter. So whenever we go for high resolution urban modeling, we need to even update our land surface parameter along with our LULC for getting the better results. So improved results. Similarly, in wind speed, you can see that RMSE is high, and that is mainly because of in this mod simulation, we have not included the 3D information, because wind speed is mostly dependent upon 3D geometry of urban area. So this, if we include 3D geometry, then we can improve the wind speed also. Now, if we have evaluated the model for performance with the ground-based observation IMD values, and we can see that there is a very good RMSE values could be obtained in temperature, relative humidity, and very high correlation. Like you can see the correlation value is very high for all these parameters. Now, when this has been validated with respect to modest land surface temperature data, and we have shown like how this value has been there. So we can see that -1 to +1 degrees and difference range, almost 85% of the pixels fall into this range. So that shows a very high accuracy of modeled output. Now we can see urban heat island formation especially during night hours in Delhi urban agglomeration. So you can see there is this is during the summer season, like you can see a very interesting urban heat island formation in Delhi. Similarly, it is in monsoon season and even in the winter season. Now, when this diurnal profile of urban heat island has been studied, so we have seen that in summer season, morning 11:30 to 14:30 IST, it shows negative heat island intensities. And it is mainly because of like bare soil area or fallow land area that heats up faster than urban area. And since the past time, after that, once urban area also gains heat because of low albedo material of urban area, they absorb heat for a long time and then they start emitting. So you can see that nighttime heat island is very, very prominent. But daytime heat island, especially 11:30 to 4:30, that heat island is negative heat island. And that is mainly because we are already discussed there is a lot of bare soil and fallow land in surrounding area of Delhi. Now, if we look at canopy layer heat island, that is temperature at 2 meter. So that also display the nearly similar phenomena where it shows 8:30 to 5:30 shows the negative heat island intensities. The similar thing can be seen in winter season also, like morning time. It is showing the negative heat island intensity. And mainly the reason is shading due to 3D geometry of urban areas and inclined elevation of sun. So it gain heat slowly as compared to your surrounding rural areas. So that is, and similar phenomena has been seen during winter, like when for canopy layer heat island also. So now this is a very interesting phenomena which we had observed, because lower surface urban heat island and canopy layer heat island at 11:30, it raises a concern for use of thermal remote sensing satellite. See, we are using thermal remote sensing satellite. Their past time is generally 10:30 to 11:30 for SUHI studies, especially in arid and semi-arid region, which is surrounded by agricultural cropland. So you can see that sometimes your heat island phenomena may not be so prominent in thermal remote sensing satellite because of this phenomena available. Now, this we were talking about all urban heat island and how remote sensing can be utilized or modeling approaches can be utilized for your urban heat island studies. Now we come to your there is one. See, most of your urban land use, land cover classification is your residential, commercial, industrial. But sometimes this classification system generally don't do not corroborate with your climatic units, like, because we had already discussed that the height, that openness and density of your roughness feature, your material or your metabolism, they have an impact on urban your climate. So with that point of view, Stewart and OK, they have defined one local climatic zone classification system where they have given 10 urban classes. One is your compact high rise, compact mid rise, compact low rise, open high rise, open mid rise, open low rise, lightweight low rise, large low rise, sparsely built, and heavy industry. So, and they have given 7 land cover classes. So if we talk about urban built up classes, like compact high rise means building are high rise, but they're dense mix of tall buildings. And compact mid rise also, they have 3 to 9 stories mid rise building. And compact open means they have open arrangement of building, like there is a lot of vegetation also in between. Open mid rise, open low rise. Lightweight low rise is basically your lightweight material like wood, thatch, or corrugated metal, sorry. And large low rise is basically those areas, like you can see these kind of development in your malls where there is a large like building are there, and they have very few trees, very few unpaved area, mostly paved. Similarly, sparsely built and industry area. And the 7 land cover classes, they are also based on your openness and density of your tree elements. They have been divided into dense trees and scattered trees. And then bush and scrub based on height, and low plants. Low plants is generally includes your natural grassland, agriculture, and urban park. Bare rock or paved. In paved area, it includes a paved area also, like whatever the paved area in urban area, it includes this class, it is included in this class. Then bare soil or sand and water. So all these this classification system is given by Stewart and OK. And there is a one initiative which has been taken by World Urban Database and Access Portal tool. And they have given one methodology using open source data and open source GIS softwares. So this is available where we can select our region of interest. We can use Landsat data. We can digitize training sets for each climatic zone map. They have given the methodology. That methodology can be seen on ViewDopt site, and this local climatic zone map can be prepared. Now, on ViewDopt site, they have given a tool. You have to just digitize your training sets, and after that, if you those training sets, once you add into your tool, then you can get your local climatic zone map. So we had prepared a local climatic zone map of Chandigarh for 2008, and we have prepared one 2015. So you can see that there is a, like, if we look at the stats, so we can see there is a significant change in area, mostly like compact high rise, your open mid rise. So high rise classes has increased in urban area, but your some of the classes like open low rise has decreased, your low plants has decreased, and some of the vegetation classes also shows a decrease, but heavy industry and other area, they shows an increase. Now, this land surface temperature of the same date has been utilized to study how different classes behave with your land surface temperature. So we can see that compact heavy industry is giving the highest temperature, and next is your compact high rise area, and even dense trees also, and water is giving quite a low temperature area. So this is phenomena seen in 2008, and similar phenomena is seen in 2015 also, where heavy industry has shown the highest temperature and water has shown the lowest temperature. And second lowest temperature is shown by the dense trees. If we see that how temperature has changed from 2008 to 2015, we can see overall there is a increase in temperature from 2008 to 2015, and heavy industry is showing the highest, compact high rise and heavy industry is showing the highest temperature. Now this bias from mean temperature was also studied. So you can see that this is heavy industry, compact high rise area. So they are showing the highest temperature, and dense trees, water, they are showing the lowest temperature. So this is like we can use this remote sensing data in a different manner, like land surface temperature, to study different phenomena of your urban microclimate. Like we can see the difference between built up and non-built up. We can see the difference between different built up classes. Then how which built up class or which area is contributing more towards the temperature gain, that also can be studied. Now, the second phenomena which is there, like wind speed. So wind speed is generally lower in urban area. We can, that is because of your tall buildings, they form the barriers like building, and they create rugged relief which lead to turbulence, and they create this kind of three different phenomena where like they have isolated roughness flow, depending upon your packing of your roughness material. And it is also studied and said in your literature that adequate ventilation, they can assist in mitigating UHI effect. So we have used remote sensing data to study this aspect. For this, what we had done, we have taken very high resolution stereo pair, and this high resolution stereo pair was first processed. This is we have got a very high quality ground control point from the ground using DGPS, like differential global positioning system, with very good RMSE, and we created the ortho image. This ortho image has been utilized for digitizing the building footprint, and this stereo pair has been utilized to obtain building height. So based on this, 3D model has been generated. So this is similar thing we have done for there is different methods can be utilized, like building polygon can be manually digitized. We can either segment the building polygons like using the object-based classification, or we can utilize even deep learning model. Or height measurement also can be done using 3D environment or through automation. Like this building height distribution in Delhi, you can see like we have done automation. It is automatically derived, like we created a workflow, and this is automatically created, and this was validated using Leica distometer from the field. So we can see that using, we have done with the data exercise with different satellites. So when we done with the Cartosat, Pleiades and ComSat 3, we can see that ComSat Pleiades is giving very good accuracy, very less RMS error and very less mean error when we measure the height from the ground. And using that Pleiades data, it is for the whole Delhi, it was height was retrieved, and we did the measurement in different height groups, and we can see that most of the groups that RMS is very less. It is less than 1 meter, and that is very good for our even climate applications. Now this 3D building database has been utilized, like this has been created, this tool Urban Morphology Extractor. This tool has been generated at IRS, and here we calculate frontal area index, zero plane displacement height, surface roughness, sky view factor, height width ratio, etc. And input data is your 3D building database. Like this is your 3D building database that can be, that building shapefile can go as an input. And based on this, frontal area index has been computed, and based on this frontal area index, this average roughness length has been computed at 50 by 50 grid, and frontal area distribution. And then you can see different parameters, like this is surface roughness length, and this is zero plane displacement height. So different equations are there which is used, and input data is your 3D database. And after combination of this, like there is value range, and based on this value range, this ventilation map has been generated for Dwarka subcity. Here you can see that there are few of the area ventilated, partially ventilated, and you can say blocked or weak ventilation. Now there is a temperature sensors, temperature data has been collected at different location, temperature and wind speed. And what we have seen that ventilated area has lower temperature and comparatively higher wind speed as compared to weak ventilation area. Weak ventilation area has higher temperature and lower wind speed. So that itself shows that if we have proper ventilated urban areas, that also can help in mitigating the urban heat island effect to some extent. Now, all this I talked about that urban heat island, urban area, urban microclimate. Now there is one more phenomena, that is heat wave. Although it is very much of a regional phenomena, but urban area, they are much more vulnerable because of pre-existing UHI phenomena. And this UHI also provides a positive feedback to heat wave. So its intensity and frequency increases. So we need to very much understand the impact of urbanization on heat wave. So for this, what we have done, we have used MODIS LST data, because that is available, daily LST is available. So using this MODIS LST, Python code has been written in Python, and the heat wave indicators, 7 heat wave indicators were computed. That is average heat wave duration, maximum heat wave duration, cumulative heat wave days, maximum heat wave events, maximum warm days, maximum heat wave temperature, maximum warm day temperature. And once they have been combined to get the combined heat wave indicator, and your LULC transformation and population layer has been combined to get the risk and vulnerability layer and hotspot analysis. So here you can see that maximum heat wave temperature, like how from, it has been computed for 17 years, like from 2003 to your this 2020. So you can see like how it has been changing over a period of time. So it is very interesting phenomena to see that if we divide the whole area, whole temporal duration into two parts, like 2009 and before and 2009 and after. So we can see that there is a considerable area, highest range in temperature in year 2005. And this in this last decade, your frequency of heat wave has increased a lot. Maximum heat wave temperature has also increased. And if you look at the duration also, duration has also increased in this decade, in last decade. So most of the time there is an increase in, after 2009, there is an increase in area under highest range. So you can see that there is a change in area, which is coming under highest range. If you look at the heat wave duration, longest duration, with that also shows the similar kind of phenomena. Like you can see that there is a increase in your after 2009, your 7 to 9 category that has increased with consistency. Now these all are heat wave indicators combined together, and there is a, using AHP, a combined heat wave indicator was created for Delhi. Here also you can see some of the hotspot, like especially in Delhi and nearby Haryana region, and some region of Punjab and UP also showing high heat wave with respect to intensity, duration, and frequency. Now, this is one land use transformation layer was generated using AWIF's classified data. This data is freely downloadable from Woven. And this has been taken from 2005-6 to 2015-16. That cycle was taken, and we can see that based on like the land use change, which is giving a positive feedback to heat wave and which is giving negative feedback to heat wave, that has been classified accordingly, given the ranking accordingly. So you can see that this it's giving very, there is a built up to built up transformation is very high in this area. So then you can see that GHSL population layer also, that is shows the this is downloaded from Global Human Settlement. This has a resolution of 1 kilometer. So after we can see that there is a high vulnerability of NCT Delhi. So this is equal interval has been used to classify the value, and we can see that high vulnerability of NCT Delhi and its surrounding with respect to heat wave frequency and other indicators. To study the impact of urbanization on heat wave, their land use transformation, like built-up change, has been studied from 2005 to 2015-16, and all indicators has been studied. So we can see that during 2015-16, there is a very significant change in the value of your heat wave, all heat wave indicators, and it shows very strong correlation of but change in built up with your, like increasing built up with your heat wave phenomena. So there is a less increase in heat wave intensity as compared to, intensity has not changed much, but duration and frequency has increased significantly. So built up has pushed heat wave duration and frequency, and definitely it has an impact on human life, health, and biodiversity, even your crop, land. So much of area is going to affect. So now, if I summarize the whole thing which I have shown you, that geospatial data provides you the multiple data sets at varying scale and resolution, and it can be utilized to study your urban structure, urban geometry, urban fabric, urban metabolism, various aspects of your urban heat island, for modeling, high resolution urban climate modeling, for ventilation patterns in urban areas, and it can be utilized for heat wave analysis and hotspot identification within the urban area. And it can also be utilized for detailed parameterization and classification of urban areas for weather models. So all these, this can be very, it provides you ample data set and has very high potential for studying urban area with respect to your urban climate and heat wave. Now, there are some of the key resources which I have used. There are some of the papers, very common like papers. And thank you very much for your patience listening. And I am open to the any question now.
To all the participants, ma'am, your previous lecture and this lecture has been appreciated by most of the participants in like chat box, which I could see, and in
Thank you very
WhatsApp group
much.
that I'm having. So, ma'am, thank you very much. I am having certain doubts, ma'am. Like I have been using mono window algorithm. So while searching in the, let's say, literature, the single window algorithm, split window algorithm, or let's say mono window algorithm, which one you feel is better for finding the LSTs?
It is very much dependent upon your area. You cannot, there is no thumb rule, or you cannot fix any such. You may have to use all these algorithms. Even radiative transfer equation is also there. So you can use those algorithms, and then you can check with your IMD data. See, generally air temperature and surface temperature has a difference of 3 to 4 degree or 5 degree. So whichever is your closest to your this surface air temperature, then that you can utilize for your.
Ma'am, but those convergence from air temperature to surface temperature or vice versa.
No,
It's,
don't do
yeah.
go into that, because that is also not a linear relationship.
Yes.
So you just check with your surface temperature and air temperature. And I have told you that air temperature is generally depending upon the area, that also like it has difference of 2 to 5 degree from air temperature. Air temperature is generally lower during daytime than your surface temperature. So whichever is closer to your air temperature, that you can use.
And ma'am, one more thing, like you have done the extensive research on this Wood Up LCG classifications of different cities.
Yes.
Like considering Chandigarh, because it might have been very easy for you to adopt Wood Up classification due to its planned nature. Like I had seen work from Professor Rajshri Kotarkar also on Nagpur. So how easy it was for other urban settlements which are unplanned in nature, like you have done for other settlements also.
My experience with UDAPT LCZ classification shows that Chandigarh also has its own share of problems, because Chandigarh has lot of vegetation. So sometimes your built up area is hidden under your vegetation. So we face issues in Chandigarh also. I have done Jaipur, I have done Delhi. Jaipur was comparatively easy as compared to Delhi was very complex, very complex. Because sometimes when you take your training samples from Google Earth, you need to match the season. That seasonal aspect is very prominent in Delhi. Like if you take, suppose you are taking the Landsat data of March, and you are taking training samples for Delhi area, suppose for the image of October, Google Earth image is taking the image of October. Then your classification, there is a lot of misclassification. So there is that seasonal aspect is also there. So I found Delhi is very complex. Chandigarh also we faced some issues because of this vegetation cover, and Jaipur. But overall, my experience with all these LCZ, VUDAT LCZ classification shows that your built-up class accuracy is comparatively lower than your land cover classes. Land cover classes are very well extracted from your VUDAPT class, like VUDAPT methodology. But built-up classes has lower accuracy when you do VUDAPT classification. So we need to develop methodologies where we can have a better classification of urban areas also, because in VUDAPT, your height is not included in your classification.
Like
it
the
is
methodology
dependent
that
upon 2D data only. And in another thing, your development of Delhi or development of Indian cities is very different from your European and American cities. It's very different. So that I have found that we need to develop some alternate methods.
Ma'am, the methodology that you proposed for Delhi in a research paper that I studied from yours. So the methodology that you have proposed for Delhi, it is very helpful to conduct, let's say, good apt classifications, good apt LCC classifications for Indian cities. So I'm very thankful for that paper also, because I studied that and that has helped me a lot in my doctoral studies also. So, ma'am, thank you very much for the an exhaustive presentation which led to a more understanding. I would like to invite some participants also. Any participant who want to have any discussion? It's quite difficult for all of us to connect to Shama ma'am, because she remains very busy and we have to take like scheduled meeting. Oh, I have ma'am, 1 minute. I'm really sorry. I have allowed most of the participants to unmute themselves. Kindly unmute yourself.
Hello.
Hello, yeah.
Ma'am, this is Sachin Vellekar. I'm from Goa University, computer
Yes.
science graduate qualified. Ma'am, I wanted to ask one question, and I was like after listening to your sessions, I was reading some of the content related to coordinative reference station and crowdsourced data. Sir, ma'am, is it same? The concept looks little bit similar. What is the difference between this crowdsourced data and reference stations?
See, if you talk about course, you are talking about course stations?
Yeah. Course. CORS, correct.
CORS. CRS is basically continuously operating reference stations. So these course stations are basically, they are continuously operating stations in DGPS mode. Okay. And they give you the very accurate locational information, as well as they provide you very accurate locational information they provide this course station, and they are mostly used for your studying the geodynamics of your urban area, not urban area, it's a whole area. Geodynamics means
Urban area also, no? Urban area also, no? It's not used for urban.
Any area.
It can be
is
used
not
for urban
specific to urban area. It can be used for any area. So course station are installed at various locations, and they give you change in your your change in the plates, this Eurasian plates and your Indian plates, they go over each other. So they help you to study that dynamics, like in millimeter levels. Okay. That is the course station. When we talk about crowdsourced data, that is totally different. Crowdsourced data means you are trying to obtain data using the people or the crowd, or like you have given, suppose, mobile app to different people, and they will, like Google Map is one of the very good example of your crowdsourced data. Like you place a location of your ATM, you place a location of hospital, you place a location of, that is basically most of the Google Earth data is collected through your crowdsourcing. Whatever the detailed information you find on Google Earth data. So that is crowdsourcing.
If that system is already available, then do we really need this crowdsourcing system? Can't we not use this system in Google Maps course system? I'm just
both are totally different systems, are used for totally different purpose. I'm sorry, Sachin, I had started. This crowdsourcing is totally a different concept, and course is totally a different concept.
Okay.
Course is used for your geodynamics study, and crowdsourcing is used for your getting the information about your assets, facilities, and maybe other attributes also. But they are totally different concept, and they are totally used for different kind of studies.
Okay.
Any other questions from participants? Ma'am, thank you very much
Thank
for
you,
the
Manoj.
second session also.
It
Thank you
was
very
my
much, ma'am.
pleasure. I always, it is my part of my job to like spread the awareness about remote sensing GIS application and making people aware like how extensively this data can be utilized for different urban applications.
Thank you. I'll
Yeah.
remain in touch with you. Thank you. Thank you very much, ma'am.
Thank you very much.
To all the participants, it is again requested that you should fall in discussions with the speakers instead of remaining mute spectators or listeners, or even just by switching on your mobile and leaving it aside. So I again request you all to kindly remain attentive. Our second session will start at 12. Professor Milap Punia from JNU will deliver the second session. To all the participants, we are having our valedictory session at 4. Architect Habib Khan, who is currently President, Council of Architecture, he'll be our chief guest. Our Vice Chancellor D. Murthal, Professor R.K. Anayat will be guest of honor. You all are requested to kindly remain available in the meeting. And let's say during this break also, because there are continuous two sessions by Engineer Sumit from Punjab Remote Sensing Center, Patiala. And then I was supposed to deliver one talk. So it'll be good if we can like finish my session and this duration which we are getting for half an hour. So I hope we can start my session, and then we'll be having is gap available, which will be from the point of view of like, let's say, transition from the technical sessions to valedictory session. Mohammad Shahida ji, I have muted you twice. I'll make you go out of the meeting. I tried to not to allow participants to unmute themselves. Mohammad Shahida ji. My session was more on, let's say, remote sensing and geographic information applications and what kind of research we assume in future. So starting with the remote sensing and GIS, remote sensing and GIS often works hand in hand in mapping. I don't have any kind of PPT as to say the type of research that I have been involved in and I have studied across and have heard from different scholars. So if you talk broadly in the manner of remote sensing and GIS systems, they often work hand in hand in mapping, analyzing, and disseminating spatial informations. As a science of obtaining information from a distance, remote sensing extracts specially explicit attributes about Earth and Earth surface, land surfaces, using images acquired from aircrafts or satellites, and nowadays UAVs also. So such attributes can be then stored, managed, analyzed and displayed basically by using GIS and remote sensing softwares in conjunction with the auxiliary GIS data representing landscape features, for example, topography, soil, roads, then sensors and political boundaries, to broadly in 3 categories or 4 categories. First, which can be map spatial patterns of the attributes of interest, then to identify their relationship to other features, then to determine how to attribute these attribute changes over a period of time, and basically the time series analysis, and then estimating new characteristic or emergent properties from existing remote sensing products. In essence, remote sensing basically provides invaluable spatial data, which is often in raster format, to the GIS for further geoprocessing. Vice versa, many critical analysis of remotely sensing data, such as let's say registration in terms of geometric means, then radiometric corrections, image classifications, and change detection, which can benefit from the use of ancillary GIS data and geoprocessing procedures. For example, masking, overlays, proximity analysis. The integration of GIS and remote sensing has been successfully applied in many fields, which are related to natural resources, environmental sciences, urban settlement planning, regional planning, then analyzing this data, including agriculture, forestry, land use, biological conversations, ecological restoration, and natural hazard management. With the recent advancements in computing innovation, artificial intelligence, and big data sciences, the integration of remote sensing and GIS is basically approaching, let's say, a new phase that will further enhance the analysis of spatial data from various sources. In terms of GIS technology advancements, if you'll see government agencies, non-profit organizations, and then private companies, all of these organizations are benefiting from the innovations in GIS and remote sensing. Researchers and entrepreneurs have found a variety of creative ways to use these GIS and remote sensing applications to advance business and technologies, which may be easily seen in the form of Ola, Uber, these kind of things, where you can get minute-to-minute information of your travel, and that can be easily seen in the format of, let's say, you can visualize where your relatives are, the latest GIS technology development, which makes way for the new applications and for the convergence of GIS with other emerging tools. The evolution of GIS is basically far from over, with exciting new softwares and methods continuing to the change in the way the people utilize this technology. You might have seen different speakers who have spoken on these different terms, where you'll find, like, let's say, starting from Professor Jeet Kumar Gupta, who has spoken on the how these remote sensing and GIS technologies can be applied on urban planning, and then to Dr. Shama Gupta, and then who spoke on basically how to find various problems of the urban settlement or regional settlements, how these land use changes or land cover changes can be attributed to these kind of these kind of problems. So looking at the evolution of GIS, which is like now developing by using new softwares and methods, continuing the change of way people utilize, like architect Nikhil Berwal utilized GIS in integration with the parametric softwares. So these are the new techniques that people are using, and with the advancements in the parameters which will decide future remote sensing in GIS, three parameters are basically majorly contributing. One is real-time data availability. Like most of the participants were concerned about how this real-time data, with the advancement in the geostationary satellites, we can use this real-time data availability. And second is the consumer-facing information. What type of information consumers are basically willing to get. And third is the application of artificial intelligence of in GIS and remote sensing, where updation of like computational applications will lead to real-time data capturing, analysis, and then procurement, and let's say then providing information for decision making. So regarding real-time data, the ability to collect and analyze the data in real time brought GIS to a new level. This development basically improved research progress, mapping systems, but real-time geospatial data can benefit consumers too. For example, location-based services like Uber are among the most common users for up to the date, up to the minute even, rather to say, geographic informations. Consumer can track their drivers and for fleet management systems, and how long it take to arrive to a particular station, particular location. So the app also employs real-time data to match users with the closest ride. They can they can choose their direct drivers. They can to find the hotspots based on the frequency of ride request. So these consumers are basically getting benefit from using the geospatial technologies. So real-time geospatial intelligence can also be very effective way to track developments during natural disasters, and even urban planning, let's say, infrastructure developments. Analysis of everything from shifting weather pattern to social media post highlighting location. Like yesterday, architect Nikhil was talking about the social media post where text forms can be converted into the geospatial location data, and how these text are basically appearing in a particular part of world or a particular part of city. So that can be tracked very easily. So natural disaster, or even based on the social media post in integration with the GIS technologies, they can easily drive out what kind of, let's say, if riots are going to happen. So that crowdsourcing data that Dr. Shama was talking about, and one of our let's say participant was also willingly asking that, Sachin Varle. So he also basically described about all these crowdsource management. So by posting and tracking all these things, the social media post in integration with the GIS technology is basically highlights location in urgent need of relief efforts. Same you might have seen during the time of this pandemic also, where trapping of people based on their geolocation or georeferenced location, it becomes very easy for government agencies to track a particular person and see the moment of that particular person if he has got infection right in the very starting phase of the COVID. So emergency management services basically use GIS platforms to generate crisis map based on a combination of, let's say, satellite imagery, then remote sensing readings, statistical model, and then to crowdsource data. When facing time sensitive decisions, it is important to have the most relevant and accurate data. And if GIS is producing that kind of data, it becomes very easy for all of us to make those decisions. Robust geographic information is boon to the organizations and individuals. That's how this Google is basically driving all these maps, and our it's basically using all these information which are in the form of georeference data through crowdsourcing, through the use of mobile phones and integration of AIs. If you have heard Sundar Pichai talking about the artificial intelligence system that he is developing at Google, they'll be tracking all of us in the form of, let's say, individuals striving to make well-informed decision and ongoing refinements of, let's say, real-time data analysis, which are vital to the future of GIS. Then coming to the consumer-related, which facing information, geospatial data has helped companies in a wide range of industries which are streamlined their operations by providing, let's say, visibility to into the key asset, uh, guiding more efficient supply chains. But everyday consumers can also take advantage of current trends in GIS. Some of the latest GIS technologies have brought, let's say, consumer facing data to the forefront, empowering smart decisions in many areas. Considering home buying, a home might be, let's say, in your price range, but the neighborhood that you are willing to go, it might have a totally different taste. It can make all the difference in whether it's the right choice for your family or no. That's why the real estate applications are now using GIS platforms to give prospective home buyers insight into the areas they are considering. In apart from the interior that they keep on showing, earlier they used to develop a home, and by developing that home, they used to show the photographs. And now, along with those interior photographs, you also need the information about the surrounding areas, the abutting areas, how much development has happened. So these, let's say, real estate companies are basically now using GIS platforms to give this prospective home buyers insight into the areas they are considering. Dozen of map layers let users review details like distance to various amenities, school districts information, or maybe like what kind of facilities or amenities are available in the vicinity. People aren't just looking for the photos of home which are searched on the websites anymore. They are scoring details about what it feels like to live in an area. The health and wellness industry underwent a major shift in recent years, with many consumers applying data to manage their own lifestyle. For example, wearable technologies let individuals track their heart rate, steps, sleeping pattern, and footpath, and the paths they follow while running or walking. If you'll see with the geospatial information, personal fitness goals become more attainable. The people keep on tracking their things with the help of GIS technologies, and then these advances have even made a mark in college and professional sports. Coaches can factor the personal data from players, GPS enabled wearable into, let's say, their strategic decision making, snagging victory while minimizing the chances of injury. So these are the type of information which basically integration of different applications into GIS by using, let's say, georeference information, they are utilizing in the form of sports, let's say, personal usage, or let's say even the home buying industry. So GPS or GIS systems are basically penetrated into different segments. Considering the artificial intelligence for future, as artificial intelligence is another rapidly evolving technology that has been applied to GIS projects in recent years. If you'll see one important application, for example, Geo AI is planning urban infrastructure and tracking changes in an urban area over a period of time. So that will lead to identification of how much development has happened in terms of urban infrastructure. For example, researchers in, let's say, LA wanted to know how land use and roadways impacted air pollution, and in turn how pollution would affect the health of local residents. There are different data loggers which have been implemented in Delhi city also regarding the similar kind of things, that how much air pollution changes have occurred over a period of time. So these georeference information will lead to effect of health in local residents. So all the local residents information will again be provided. Wait a minute, so all the participants are again requested to kindly remain available during the valedictory session. And before valedictory session, we'll be having a, let's say, discussion. So all the participants will be required to switch on their cameras also from 3:30 to 4, let's say. Yeah, 3:30 to 4. So during this period, we'll be having discussion on various topics that have been covered. So that all of you are requested to kindly remain available during that particular session. Maybe through YouTube link, or maybe through this thing, what they call Zoom meeting. So we should be available during those particular sessions. Although those sessions from the technical point of view or the attendance point of view may not be important, but they remain important at the time when for the let's say concluding sessions. So looking at the different examples that I was putting forward into the artificial intelligence, where health information was collected by the GIS apps, and these GIS apps are basically then trying to analyze what kind of, let's say, measures could be taken or policy decisions can be taken to, let's say, avoid the health issues in a particular region where, let's say, pollution is being occurring. So by using the information to predict when pollution level would become dangerous, the city could issue warnings as early as possible. So this kind of thing can happen at a very faster rate. So these kind of decisions can be taken by different governing bodies. So that will lead to help in making decisions in time. If you see in another project that utilized, let's say, GeoAI, Kuwaiti government officials wanted to make it easier for the citizens to find product and services they needed at the time of, let's say, they needed by using an application. Like many big cities, traffic congestion was a major obstacle. The government wanted to be able to tell the users what road conditions were they like to be there at the given point of time. Thus, you can easily see in Google AI also. The applications gave users the ability to share whether they were seeing heavy, moderate, or light traffic. This, by using the crowd searching data, Google is providing a similar kind of information, which, like for the Kuwaiti government, helped the researchers identify the traffic pattern. So when there was heavy traffic on one route, the application would driver the directions to avoid traffic jam. These kind of applications initially relied on user input and manual updates, let's say, to identify the traffic, requiring constant adjustments to machine learning algorithm. With the introduction of GeoAI, the application gained a deeper understanding of traffic conditions and greater predictive capabilities, which in turn led more useful driving instructions, if you'll see in these kind of conditions. So GIS is still evolving and has a potential to be one of the future trends in GIS that makes the biggest impact of daily life. In addition to the land use and infrastructure analysis, GIS can also be applied to health systems, agriculture, many more industries. The top 6 industries for GIS, which are basically, let's say, supply chain management, insurance, forestry and timber, then urban planning, banking, and health and human services. These are the topmost 6 industries that are going to be there in future. If you'll see the supply chain management over recent years, the processes of bringing products and services to the public have evolved immensely due to the changing customer preferences and rapid growth over, let's say, um, e-commerce. Today, the ability to track shipment and inventory can make the supply chain more efficient, saving more money for businesses that uses GIS, and that saves a lot of money in terms of, let's say, by improving upon the supply chain management. One example is delivery of the project produced to supermarket around the world. Agriculture products are picked on small farms and then distributed to grocers in many locations, often crossing states and national boundaries. So this has become very easy for uh, supply chain management industry to through the usage of the GIS. The produce must arrive on top condition, ripe but not spoiled. GIS technology can tell agriculture and supply chain professions when fruits and vegetables left the field, what route they are traveling, and what quality will be happening upon the arrival. If produce shows up the supermarket looking up, let's say, non-satisfied, workers can retrace the items part to identify problem areas and improve the odds that future deliveries will arrive in better condition. So this can happen very easily by the usage of GIS technologies. Sorry. In terms of industry of insurance, if you'll see, insurance companies rely on accurate predictions to determine risk. So a wide range of factors come into play, but in nearly all insurance sector, location is the strongest indicator of risk. And because if you'll see the diseases or the pattern of disease or the, let's say, food habits of a particular region, where, for example, Punjab is having food habits of eating non-veg, or southern part of India, you will find most of people consuming non-veg. In northern part of India, you will find wheat as a major source. In southern part, or let's say the central part of India, or eastern part of India, you will find rice as mere consumer. So the type of disease that are going to happen will be covered or not covered in a particular policy that can be determined very easily based on the, let's say, this geographic information systems that we are developing. So certain regions are more prone to earthquakes. Disasters prone area can be identified, and social factors like propensity towards crime that can be plotted on GIS and can be very helpful in making decisions for the insurance agencies, which tend to like cluster in specific areas as well. With the improved predictions, insurance companies can set coverages rates more appropriately, and GIS softwares allow professional to map risk levels based on the information. For example, historical records of all these what they call disasters that can happen, or which could highlight the livelihood of an occurrence like a hurricane or earthquake, or any sort of, for example, even man-made crisis also. So demographics which might give insight into whether the people are likely to be involved in a car accident, that can be easily tracked upon by using the historical data, which if we'll try to put up in geo-referenced format and trend specific for a number of years. Local geography, for example, road accident planning, the road planning, which is basically government of India is targeting zero accident, zero fatalities on roads. So that can be easily tracked. If most of the accidents are happening over a particular location, it means there are problems in that particular location, which may be related to the, let's say, design of the road, or maybe because of the behavior of that particular community, in that particular, let's say, residents of that particular area. So local geography, which could indicate the possibility of an event such as landslide. So these becomes very easy to track down. So forestry and timber, if you will see, in forestry, in a complex forestry and timber is a complex field that analyzes condition of wooded areas to determine how to best, let's say, utilize land, preserve ecosystem, or efficiently plan harvesting. So that can use it. And if you look at the urban planning perspective, planning a city takes more strategy than simply identifying vacant lots and constructing infrastructure or buildings in them. The placement of business, government, public, residential structures impact the quality of life, and quality of life of citizens who basically live at that particular location, or the resident of that particular city. a modern city grows, planners have less space to work, and when they need to add a building or road or replace aging infrastructure, it is difficult. But with the help of GIS, it becomes very easy. Developers must also account for the impact that they may have on animal or plant life or the ecosystem or environment that we try to preserve. So to responsibility accommodate a community citizen while minimizing harm to existing structures. So that becomes very easy. So that's how we rely upon the GIS technology. We as a planners or city developers basically rely on GIS technologies. Planners can also review spatial information and determine the most efficient way to introduce alternative energy resources for a city. The solar panels installation, which becomes nowadays a trend in the Indian subcontinent and in western part of the world also, for the developed countries. So it becomes very easy for the planners to identify those locations where these, let's say, rooftops can be easily identified, where solar or alternative energy resources can be identified. So GIS mapping may help identify the best places to build out wind, solar farms, or install renewable energy infrastructure on a smaller scale, like underutilized parking lots also. So that can becomes very easily and can help the planner. This GIS technology can help the planners or the developer of these infrastructure facilities in terms of banking. When banks choose their branches locations very carefully, if you would have seen the ATMs, they the ATM location of ATMs or any supermarket or even healthcare facility, it becomes critical to identify the location for the consumers. If the minimum, let's say, economic viability of these particular ATMs or banks are not there, they'll need to change their location. So for banking sector, they choose their branch locations considering the factors like potential customer base, local crime rate. So all these things are very important. So banking also, people start identifying, let's say, these locations based on the financial institutions. They make strategic decisions. And oh, it seems Professor Milap Punia has joined. I'm really sorry to stop this at this point of time. We'll keep discussing after Professor Milap Punia's lecture. Good noon, sir. Hello.
Hello.
Sir, good afternoon.
Very good afternoon.
I'm really sorry because Professor Shama left early. So my session was there in the afternoon. So I started delivering my portion.
No, it's okay.
So, sir, we can start with your lecture. Professor Milap Punia from Jawaharlal Nehru University is there. So, sir will basically deliver on the things that I was talking about. So at that point at the same time, sir has, let's say, because I have already introduced to all the participants, sir is basically professor and chairperson for the Center of Study of Regional Development Center at School of Social Sciences, and one of the founding members of Special Center for the Disaster Research, SCDR, JNU, New Delhi. So I have already introduced sir, and sir has already delivered one lecture. I invite you again, sir, for the second session of day 5 of the final day of this FDP. So thank you very much, sir, for being on time and delivering the expertise that you are having, sir. So thank you, sir. And welcome again, sir.
Thank you, Dr. Manoj. Okay, so today is a very important day. As you all know that ISRO has launched successfully a set of satellites through PSLV C-52. So I hope many of you have seen the launch. So this satellite carries microwave sensor, which is like you can say they are calling it Earth observation sensor. It is a microwave sensor, and in this microwave sensor there is a C-band antenna. Earlier, if you are aware of RISAT 1A, So this is that was RI set 1. So you can say this is RI set 1A, which has resolution of 2 meters. Okay. This could further be improved with the resolution of, say, 0.7 meters. That means 70 centimeters, right? So that is the one highlight of today's launch. So what I will do is, because these launches are very, interesting, and they visually they look so big, fabulous, you can say, right? When a launch vehicle take off from the pedestal, and it is a complex operation. There is a maneuverability, very complex maneuverability in various phases of satellite launch. तो मनोज जी, मैं इनको थोड़ा सा एक वीडियो दिखाता हूं जो अभी दूरदर्शन ने कैप्चर किया.
Yes, sir. Yes, sir.
बहुत अच्छा लगेगा इनको भी. और फिर थोड़ा सा क्योंकि आपका जो ये कोर्स है, बेसिकली इट इज टॉकिंग अबाउट एडवांसेस इन रिमोट सेंसिंग GIS. So far we know that there are optical sensors which are giving us remote sensing data sets in a visible region of the electromagnetic spectrum, say from 300 nanometer to, say, to even to thermal 12.5 micrometer, right? So that is the capability of these passive sensors or optical sensors. Now, this sensor which is launched today, which is called EOS Earth Observation 4, it is actually a active sensor which has a C-band antenna, and this is called C-band SAR antenna. What is SAR? SAR is a synthetic aperture radar, right? It is synthetically constructed. Means it is it's a physical antenna. From one side of antenna, it transmits the signal, and then it again captures the signal, right? So that's the beauty of this sensor, and they are very complex, and then the backscatter of these antennas is reproduced as images. They're produced as images. And as you know, active sensing means in all weather conditions, one can do the remote sensing. We can acquire the picture in cloudy season. We can acquire the picture during some kind of, extreme climatic events, including hazards, right? So that is the beauty of these sensors. So today's launch was actually about that. So what I will do, there is a video that is available on YouTube. I'm going to share with you. Just give me a minute, please. Hope this is shared.
Yes, sir.
I don't know about the sound, whether sound will be transmitted or not.
The sound is not coming properly.
This is the launch. Hello, Ajit. Speaking. See, this is very important for many of you who have not, understood or seen this before. When satellite is placed in a orbit, say in a sun synchronous orbit, so it has to escape the gravitational force of Earth. So India has a time-tested launch vehicle that is called PSLV. As you can see, the nomenclature this launch vehicle is PSLV-C52. So it is called as a horsepower, and this is our very powerful launch vehicle, which has been successfully placing satellites from time to time. So it has different phases, which is full with say fuel. I won't use the technical terminology. So there's a stage 1, stage 2, stage 3. So they take the launch vehicle against the gravity. And finally, these satellites, what you see in the picture, which is sitting on the assembly bay. there is a platform in the last stage. What you see, that is called assembly bay, where these satellites are placed. So the last, this is the last stage. This is the third stage that will be detached from the assembly bay. And finally, satellite will be on its own. And then satellite also has a fuel. Then satellite, by using that fuel, it will go and sit into its proper orbit. We call this particular orbit as a sun synchronous orbit. Sun synchronous orbit means it is an orbit through which, when you take the picture in successive scenes, your illumination conditions remains the same, so that further classification and standardization and comparison becomes easy. So I will show you the final separation, then we will come to our classroom. एक तो है ना, ये जब पुटअप करते हो तो इसमें नाम लिखने चालू करो, सेल्वन का भी और आपका भी और मेरा भी, है ना। एटलीस्ट एक सीक्वेंस होनी चाहिए इसमें। हाँ हाँ, है ना, प्लीज। ठीक है ठीक है, आप इसमें ना सेल्वन का
Sir, kindly unmute yourself because the office staff was there, so I muted you.
just 2 more minutes.
Yes, sir. Yes, sir.
So that was the launch that was successfully achieved today morning, early morning, 5 a.m. So if you have any question, you can ask me about these launching satellites, you know, and this particular satellite, as you might have heard, this will supplement the high resolution data in urban areas, like high resolution Indian data set is Cartosat 1 and Cartosat 2. So in case of clouds, right, or in case of any disasters, that this particular data that is through EOS, Earth Observation Satellite 4, that is also called as RISAT 1A, it will supplement the Cartosat optical data during say any disaster or cloudy season. आप लोगों को कोई सवाल है तो आप पूछिए. मुझे लगा कि आज आपको ये दिखाना चाहिए क्योंकि आज बड़ा ऑस्पिशियस डे है, right? We have been talking about applications, but you should also know how they are placed in the orbit. आप लोगों का कोई सवाल है? लगभग 100 पार्टिसिपेंट्स हैं, किसी का कोई सवाल तो होगा.
पार्टिसिपेंट्स तो 100 से ज्यादा जा चुके हैं, यूट्यूब पे बैठे हुए हैं बड़े सारे.
पर कोई सवाल नहीं आ रहा है, ये मैं ऑनलाइन में समझ में नहीं आता है.
सर ये बड़ी दिक्कत है. ओके सर, can general public can apply for these launches? Means if let's say Manoj Pawar wants to see the launch,
then no, it's not like that. Only official people are there. There are some high level officials like earlier ISRO chairmen and earlier senior scientists. They are invited to the launch, right? And since it's a very critical launch, so people are not allowed in the control room, but definitely people can see from the surrounding area. Like see, launch vehicle takes from the side of eastern coast of India, that is in Sriharikota. So people can very easily watch the sky, like from Chennai. Definitely there might be some videos that came in a local media early in the morning because it was in the night. So one can see the flare coming out of the launch vehicle. And a lot of people, they get crowded in Sriharikota outside the Satish Dhawan, space center. तो वहां से दिखाई देता है मनोज जी. और secondly, visit के लिए, like one participant is asking how can we visit, then I think from the official request from your institution, you can write a letter to the ISRO PRO and you can request them. Then I think definitely for the promotion of science and technology, they're allowing students to visit their facilities. For that, it's not like that you can walk in. You have to write to them. Then definitely they provide you a slot there. You can visit the some of the facilities of the ISRO. Okay, so this is and just for everybody's information, because when we get to know about our own space program, so we feel really excited, and motivated, and especially when you see any particular launch. जैसे मनोज जी ने बोला सर मेरी भी इच्छा थी, मैं भी जाना चाहता हूँ, कैसे जाऊं. तो ये एक बड़ा एक हमारे लिए प्रेस्टीज का मोमेंट होता है, because there are very few nations which have this capability. So India has capability to manufacture their own satellites, their own sensors, and then place them successfully into the orbit. Like for remote sensing satellite, we have a time tested now program and launch vehicles where anytime, whenever we feel need or desire, we can place a satellite of our requirement. And there is another, I think Kailash is again asking about the artificial intelligence. I think, see, these terms which are now coming. So there is a sequential progress which is taking place in the development of these algorithms or these technologies, like you are writing artificial intelligence. So artificial intelligence, you see, where do we apply artificial intelligence? We need to have a large amount of data. That data could be of diverse nature. And then there are different programs, algorithms that we apply on them in order to get the best solution out of the data set, right, in a particular thematic area. So machine learning programs are there. Some of the machine learning program, like you might be aware of, like say decision tree approach, which is applied and finally you get the best set of rule to apply on a large data set. So this is, there are scholars who are working on these technologies, and in times to come, I'm sure ISRO is also working very closely with some journals where they will be coming up with some application case studies where artificial intelligence and machine learning is being applied. Okay, Kailashji? So now let's get back to our today's objective, and let me share the slides if there are no more questions. And before going to the questions, Manoj, should we tell them about the various ISRO centers and their, because that would be beneficial for them, because there are some centers, they are also providing the training, and also, they're dedicated to the application of remote sensing. Have you told them?
Sir, not in the present FDP. Okay. In previous FDP, Professor Bhagwan Singh Chaudhary mentioned it, but not in this one.
Okay, so see, there are various ISRO centers are there. Like Tiruvananthapuram is the center which is called as VSSC, Vikram Sarabhai Space Center. This particular center does the manufacturing and research and development for the launch vehicles, like you heard of PSLV, GSLV, cryogenic engine, and various stages. It is very complex, and as I said, that we are proud that we are now self-dependent, and there are very few countries in the world who are in this particular list. And then these launch vehicles, they are brought to Sriharikota, that is Satish Dhawan Center, right? So that is Satish Dhawan Center is like our launch port. And then fabrication of the satellites. Generally, fabrication of the satellite takes place in Bangalore, and also in Space Application Center, Ahmedabad. So these two centers, along with on requirement with other centers, they manufacture the satellites, remote sensing satellites, and also communication satellites. And there are a lot of developments and innovations which are required at the sensor end, and also in the integration part of the satellite. So this is taken care by these two centers. Now, apart from say manufacturing and research and development for launch vehicles and satellites, how to make use of these data sets, right? So there are application centers in Space Application Center, Dehradun, as well as the NRSC, National Remote Sensing Center, which is there in Hyderabad. So data is downloaded in a Shadnagar and other centers, and then that data is archived and finally disseminated to the users, scientists, or to the people in academia who are interested. So they make use of the data as per their requirement, and various ministries of central government and state government, they make use of that particular data for better governance. Now, apart from that, for application point of view, especially related to remote sensing GIS, apart from Space Application Center Ahmedabad, Indian Institute of Remote Sensing, and as I said, also NRSC, Hyderabad contributes a lot of work, and continuously they are supplying data to the users. So this is quickly very broad framework of ISRO, and one should be knowing about where we should go to get the data. So for procurement of the data, one should, I recommend that you must visit NRSC website, National Remote Sensing Center website, and look at the brochures of various data products. Now, since we are, see today's lecture, if we want to focus on for urban applications, so you know that for urban applications in urban areas, there is a high density of population. There are a lot of infrastructure which is required in order to run the cities properly. And for that particular purpose, we need a high resolution satellite products like LIS4, Cartosat. These are some of the high resolution products which are available with ISRO, right? So this, as per the application, the requirements, they vary, and they are a wide spectrum of data products which are available. So I encourage you guys to go to the NRSC website, look at the data brochures, information about the data, and then one can also place the request for the procurement of the data, right? So that is the method of procuring the data from NRSC. Apart from that, there are some data sets which are available on the Bhuvan website or Bhuvan portal. Apart from, say, showcasing the applications of various ministries, central government ministries, also there are some solutions which are there in a geospatial format. They are also highlighted from the state government, right? So these are few recommendations that you must go and refer in order to understand from what are the applications and what nature of data, what type of data is suitable for your particular application. Okay, Manoj, I hope screen is visible.
Sir, it's visible, sir.
So spatial resolution is the capability of the sensor to differentiate between 2 points, and we generally we represent that in meters, right? So they are sensors which are from geostationary orbits, which has a high spatial resolution and means larger coverage. And with time, this spatial resolution has improved. As you can see from Landsat series of most of the data products are in 30-meter resolution, then to 10 meter, then Indian remote sensing satellites. Earlier IRS 1C, 1D was 5.8 meters, and Cartosat 2S, which was 2 meters. Now we have capability of advanced Cartosat products, which are less than 1 meter. And then there were also private satellites from the private service providers. Iconos is one of them. And now there are many more companies which are there, which are providing better resolution satellite products, or you can say high resolution products, say up to 20 centimeters, right? And our data selection criteria depends upon choice of your application area. Like say for agriculture, definitely you may not require high resolution data, but definitely for urban areas or some of the events which have a very high frequency, then you need a high resolution data products, right? Okay, so I'm going to skip these slides, some of these slides, because they are of transdisciplinary in nature and they are primarily related to the geography, as geography is also a transdisciplinary subject. So in order to undertake any work in urban, so as other day we were talking about that it's not only remote sensing, but we need to also get data from the field surveys, or say about the socio-economic and demographic status. So for that nature of data that need to come into GIS format. Now, directly coming to the applications in urban. Now, this is one case study I'm showing to you, where we have a 3-time period data for part of Delhi city. As you can see, the central part, which is green in color, this is our university, Jawaharlal Nehru University, and how one can use a remote sensing data in an urban area. So where there is a construction going on, which is shown in a dark red ochre color, whereas construction is complete, it is shown in a magenta color, right? So you can see the activities at a scale where we are showing within the campus of Jawaharlal Nehru University. There were activities which were happening, construction activities in 1991, which was happening on the Nelson Mandela side of the road, right? And on the Aruna Asif Ali road, right side road, you can see there's a magenta color. So there was a one research institute that is related with genome sciences. So that was construction was completed. So this kind of information can be gathered from satellite data across various time periods. So time frame for this particular information is 1991. Now in 2003, you can see the DLF mall and other malls have come into this particular Nelson Mandela Road. And in 1991, that particular development was not there. So within span of say 10 years, the sanctions were given, and after sanctions were given, allowed by say urban planning authorities, these constructions, they came into form, and finally construction got completed. And you can also see another university, Terry University in Vasant institutional area, that could be captured, that information could be captured from satellite data, and new developments can be reflected. Now that is from 2010. So I hope these slides, gave you confidence that how we can make use of satellite data in order to monitor the development in a part of city, right? Now, similarly, in 2004-05, there was a program that was commissioned by the Ministry of Agriculture, and the users, their demand was like, we have a population enumeration. Every 10 years, we come to know about the status of our population, their socio-economic and demographic status. Similarly, we should also know about the status of our resources. So then Ministry of Agriculture thought that we should have a NR census, natural resource census, through satellite data product, and ISRO was tasked to do that. Now, in order to achieve that particular objective, as in the beginning today's lecture, I shown you the launch. So as per the requirement of the country, the government sanctions, money for the launch of particular satellite. So it was thought to have a resources satellite. So that particular satellite that money was provided, and then satellite was placed into orbit. It was designed, it was fabricated, and as you have seen today's launch, similarly that particular satellite was placed into orbit, and satellite was called ResourceSat. ResourceSat has two sensors. One was advanced waves, and second was list 3, right? So advanced waves data product, since its resolution was 56 meters, meters, whereas list 3 was 23.5. So it was suitable, AWIFS was suitable for mapping, cartographic mapping up to the scale of 1:250,000. So all land use categories from since then are mapped yearly. So one can find out the transition of land use categories, say from year 2004 onwards. So now let's talk about little bit about, say, quickly, like when I'm talking about this particular point. So if somebody asks you the question, how much is the built up in our country, right? How much is the built up in our country, say in last 15 years? So we should know the figure, right? And what are the implications of increasing this built up area, right? So if I pose this question to you from the audience, can anybody tell me what is the percentage of built up of total geographical area of India? Hello? I request participants to speak out.
So shall we try it randomly?
Manojji.
If the person won't speak, I will let him go out of the meeting.
No. Don't do that. Don't do that. It is, you know, it is difficult in COVID times. The only worry is that when their cameras are not on, then we don't know whether they are there other side of the machine or not.
Yes, sir.
So that is the
In
problem.
my previous recommendation
Okay.
also.
Okay. Anyway, Manojji, we will finish our job.
Okay,
so for the information of the participants,
Sorry, sir. Hello.
the percentage of the built up is less than 1%, right? Okay, so these are few slides that was explaining these changes, say from 2000, 2004 to 2014. We analyzed these land use transitions. Now, by making use of the satellite data, as I explained you other day, that there are more than 7,000 urban settlements in India. Out of these 7,000 urban settlements, around 2,500 settlements were added in 2011 census. Now, that particular question, and to know about the location of these new census towns, whether these new census towns are isolated or they are in a periphery of large towns, say metropolitan towns, or they are in periphery of class 1 towns. So these questions, these geographical inquiry about what, where, and when gives us very good insight, and we can come out with many inferences. So one such a urban process is called peripheralization. So we have seen that in some of the state there is a strong peripheralization, means the census towns, the new census towns, which are indicating of the growth, they are in the periphery of large towns, whereas some states have shown less degree of peripheralization, like Bihar and Rajasthan. So this is one particular study that we have done for Haryana. So these slides are pertaining to that. Another one is apart, like in the beginning, I have shown you the launch of RISAT or EOS4, which is actually a active remote sensing sensor. This particular, then we have taken some example from optical sensor. Now there is a different kind of sensor as well. There is a third kind of sensor. This particular slide, what you see, this is nighttime images. So the ISRO has launched, not ISRO, the NASA, couple of years ago, they have launched a satellite called VIIRS. So one can observe the night images of the night time and can see the difference. Like in this particular slide, you can see the difference in Indo-Gangetic plain from two images, 2014, 2012 and 2016. And this can very easily can be correlated with the economic progress that has been achieved during this time. And this is reflecting the electrification, rural electrification. This can further be validated or verified by collecting the data from, say, particular state, Uttar Pradesh, Rajya Vidyut Nigam, right? So these are the possibilities. And these are some of the case studies that I'm showing you how you integrate the data in a GIS format. In the background, there is a recent nighttime image, and you can very easily see the red ochre color points that you see in this particular image is these are settlements which are mentioned in Tertius Candelius encyclopedia. So he wrote a very good encyclopedia that gives us history of 4,000 years, right, of human settlements. So these settlements in red ochre are of, say, up to 1800, because after 1800, modern enumeration started. So these represent the red ochre circles, the small circles, what you see. Whereas these green triangles, what you see, they are million plus cities. And as you know, as per 2011, they are 53 in number. So there is a modern development, or they are the old settlements which were there up to 1800, right? So one can see the comparison between them. One can identify the pattern. So you can very easily see the pattern. See, there could be a pattern of similarity, there could be pattern of dissimilarity, there could be pattern of exception. So in the area of Jamshedpur, Dhanbad, Asansol, and Ranchi, this is exception pattern. Now where there are a lot of progress which is happening, there are industrial cluster developing, but earlier this region was not that much popular. Whereas area of Khajuraho, Mahoba, Kalinjar, Chanderi, Jhansi, you can see the red ochre circles are there. So they were very prominent both economically and culturally. But whereas in terms of the urban growth, we don't see any million plus city in the neighborhood. Similarly, Amroha, Muradabad, Farrukhabad, Bareilly, and Baglan. In the southern part of India, I request you to just focus for a minute. You can see Bijapur, Badami, Lakundi, Bellari, Gulbarga, Raichur, Dora Samudra, Malkhed, So they were very prominent and economically rich areas, but now not corresponding with the current urban growth, right? So these are some insights that we get from, remote sensing GIS data sets about the knowing about the urban development in the country over a large period of time. Now, due to paucity of the shortage of the time, I won't be discussing all the slides, but I would like to show you how it can help you to capture the growth, because as we know that people migrate to urban areas in search of the jobs, and the per capita income increases when person moves to the urban area from rural area, because urban area has high concentration of service activities, or say involvement in tertiary sector. So built up is a proxy to the urban area, and this land conversion from other land use category to the urban is easily captured by making use of remote sensing data. So this red color representing the built up, and you can say it is also proxy to the urban, which is a continuous built up area. So this is image. We are focusing here on Ghaziabad. As you know, Ghaziabad district is one of the districts where very high rate of urbanization is reported in the last decade. And then second is Bangalore. So on the right hand side of NCT Delhi, there is a Ghaziabad that you can see. And I request you to just focus on the slide. This picture comes from 1991. This is 2001, and this is 2011. So you can see how the built up, the continuous built up is increasing outwardly from NCT Delhi to the neighboring districts, which includes in the right hand side, Ghaziabad, Noida, and Greater Noida. Now one can make use of such kind of data products for various applications. A guy or a student who's say interested in an environment, he can make use of this data set for environment related solutions or insight into the environment. Or if somebody is interested in studying agriculture land loss and increase in urban growth, definitely he can make use of this data. If somebody is interested in urban sprawl, he can also make use of this data set. So that depends upon your perspective. From what perspective, what application area is of your interest. Now, there are a lot of other changes which are happening, and if suppose we need to capture the development. So especially development, human development can only be captured by monitoring human indicators. So those human indicators, like say percentage of female literacy or number of schools and colleges, apart from workers category of for occupation. So all this information we need to get from other sources, and we need to integrate that information in a GIS environment. And then one can see that what are the components, major components, which are impacting the development. Now, this is one study done by the scholars where district and statewide agriculture land loss is being estimated. You know, agriculture is our Indo-Gangetic Plain and some basins in southern India. They are producing good amount of food, and in order to address the question of sustainability, we need to preserve these fertile lands also, because land is finite, as we know, and in order for good quality, good nutrition food to everyone, we need to also work on this particular area of research. So from satellite data, one can find out how much agriculture land loss has taken place in a particular district, and the aggregated value can be brought at a state level, and then accordingly a policy can be designed. So Manoj, I think should we continue with this, or should we take the questions if anybody has?
Sir, if anyone is having question.
Otherwise we will be talking, no?
Sir, Deepa has switched on her mic.
Okay. Yes, Deepa?
No. She turned off the mic, sir. Deepa, participant code 113.
Okay, fine. So let's continue for next few minutes, maybe 10 minutes.
हेलो
Yes, please.
सर नमस्ते
Namaste.
सर मैं वेस्टर्न डेजर्ट रीजन में जो सेक्रेड ग्रूव्स होते हैं सर, उनकी स्टडी करने के लिए सर ये रिमोट सेंसिंग और जेएस कैसे काम आ सकता है सर, जिनको सर ओरन बोलते हैं अपनी तरफ?
भाई Oran, when we talk about Oran,
yes,
so Oran has some kind of say stabilized semi-arid vegetation, right?
जी सर.
है ना? तो इसके अंदर जो आपकी वेजिटेशन होगी, हो सकता है वो प्रोसिपिस से रिलेटेड हो, या बाकी जो आपकी एरिड सेमी एरिड में जो प्रिवेलिंग स्पीसीज हैं वो उस ओरन के अंदर होगी. उस ओरन की जो बाउंड्री होगी उसकी भी एक अपने आप में एक शेप होगी. हो सकता है ओरन के चारों ओर बाउंड्री हो, और ये भी हो सकता है कि बाउंड्री ना हो. तो वो उसकी शेप, उसकी साइज और जो उसकी वेजिटेशन की कैरेक्टरिस्टिक्स है, वो सैटेलाइट डेटा के ऊपर हम उसको इंटरप्रेट कर सकते हैं. और इंटरप्रेट करने के बाद में आप सैटेलाइट को अगर डिजिटली करना चाहते हैं तो आप बेसिकली जो आप उसमें से निकालेंगे वो आप एक डिफरेंस निकालेंगे सराउंडिंग एनवायरनमेंट का और वेजिटेटेड एनवायरनमेंट का. सो डेफिनेटली आप उस मेथोडोलॉजी के द्वारा सैटेलाइट प्रोडक्ट से ओरन को क्लासिफाई कर सकते हैं.
ओके सर, थैंक यू सर.
Welcome.
Hello, sir. This is Alok Verma.
Yes, hello.
Sir, can we get a specific percentage of built up and open spaces of a particular area?
Yes,
through GIS?
yes. Why not?
And how much it will be accurate? Matlab, like in accuracy
See,
level of it.
see, for accuracy, you need to work out. It depends upon the person who is classifying it. And it also depends upon the nature of data and type of data. If you have a high resolution data products, then definitely your accuracy will be very good. I can say it can be around, it can be more than 95%, and that is reasonably excellent. And if you work with say coarse resolution data products, and then also you can get your accuracy around say more than 85%. So that is again very good. And as your question is pertaining to built up, so built up is very easy to bring out of satellite data. And similarly open space, because built up and open space, they all will be in a urban area. So definitely there is no problem, and you will get a very good accuracy from satellite data products.
Thank you, sir.
My suggestion could be that after extracting this kind of information, like you asked the question about open space and the built up space, so what is next? So one is a like technological input. Okay, we have done it, but how do you take it to some policy implication, right? Like what would be if suppose open spaces are decreasing in a city, right? So what should be the policy discourse, right? So when we talk about open, then open space could be used for recreational purpose. Open space could be used for sports. Open space could be used for some kind of entertainment, or open space could also be used for during emergency times for say resettlement, or open space could be used as a rescue area. So we need to articulate, take this data outputs forward, and we need to articulate about the applications and policy implications, right?
Right, sir. Thank you, sir.
So just give me a minute. So this particular slide, I'm sure this is visible. So this we published as a part of our work. Like recently we have published one paper on Gurugram, and a couple of years ago we did a work on subaltern urbanization. So you can see this is Gurgaon city, and how Gurgaon city is expanding on the left side, or you can say Gurgaon Manesar complex. So this is between two time periods, 2008 and 2013, right? And then we also made attempt to bring the GIS data set in order to see the overall vulnerability in terms of occupational vulnerability, social vulnerability, and residential vulnerability by making use of the census data, right? So this shows that some of this particular town, the new census town Gadi Hatsaru, here one can see that there are relatively good number of salaried private enterprises are there, means the enterprises which are employing the people. And this is better than the central part of the city in terms of establishing small and medium enterprises, right? So in a way, we can say that the central part of the city is more exclusionary in the nature, where the surrounding or the peripheral areas, they're providing more opportunities for the employment generation. Now, this is for seeing the trickle down, if it is happening, say from Gurgaon to to the neighboring district of Mewat. Mewat is one of the backward districts of Haryana, and now it is a part of aspirational districts. So we again compared between these, vulnerability figures that I have shown you in the previous slide, and we found that the development which is happening in Gurgaon is not trickling downing. It's not trickling to the neighboring districts. Now, from satellite data, those who have a training in interpretation of a satellite remote sensing data product, high quality data products, while doing visual interpretation, one can very easily find out informal settlements like in this particular slide, one can see the slum, Indra Kalyan Vihar, and one can also see very congested, high density urban villages. In this particular case, on the right side of this slide, there is a Tekhan village, and then there is a formal housing. So it clearly represents spatial inequalities, formal and informal settlements. And some of these informal settlements like slum, they are housing and they are enclaves of misery. And whereas from the interpretation of, you can see this HIG and MIG housing, good quality pattern of the houses represent the prosperity. But in order to prove this argument, one has to get the data from the field about income or any other variable, and then make the point forward and represent them and saying that, okay, what we were saying, this can also be correlated with the ground survey. As you can see, the high income colonies, or where there is a regular pattern of the houses, they have a high income, whereas informal settlement are actually enclaves of the misery. Now, these are some case studies. These maps represent one work we did a couple of years where we find out relative poverty at a ward level in a Jaipur city, right? And so this nature of information has 3 different levels at, say, district level, at municipal ward level, and in form of MIS data sets, information management data sets, like individual household can be identified, post deprived household can be identified. And this is part of decentralized urbanization and governance. And this definitely helps in a delivery of services. So there are many applications, but I will stop here. And if you have any questions, we would like to take your questions. Thank you. Okay, Manojji.
Sir, thank you very much. Any participant, if they are having any questions related to any of the concepts of remote sensing and GIS?
So,
Sir, I think there is no response related to.
Okay, so this is, I'm just showing Manojji last slide. So I strongly recommend that you should go to the Bhuvan Geo platform of ISRO, and you can see this is the glance of the main web page of the portal, and you can see that various application sectors, like say starting from urban, rural, tourism, groundwater, Narega, watersheds, this all is given here. And then there is also spatial applications in the form of, like say, hydrological products, decision support systems. So this all is listed here. And if you want to make use of some readily available data, then there is also 3D and 2D data sets which are available. And one of the products that I have shown you, the land use land cover changes that is happening, and that was mapped through NR census. So you can find that in thematic surveys. So this is strongly recommended. I suggest you to kindly go to the Bhuvan Geo platform of ISRO. Okay. So there is one question from Deepa. She's asking, how does real-time data in GIS is applied at the time of flood risk assessment in a particular area? Okay, so I think you forgot to mention the real-time data could be of many types. Real-time data, or you mean hydrological data, or do you mean any kind of remote sensing data? So real-time data from satellite is really difficult, right? But definitely some data during particular, say, high precipitation. So one can make use of microwave data. And if you mean it by hydrological data, then in hydrological data means you have a sensors across the watershed, and those sensors are providing you real-time data in terms of water discharge and amount of precipitation received. So this data is of very good importance in order to flood risk assessment, right? If you can visualize this in a particular microshed region, though that information should be available through sensors in a real time. Okay, so this is one. You asked the question, how does? So this is the one scenario one can visualize.
Okay,
Any,
got it.
any other question, Deepaji?
Sir, nothing. Thank you.
Okay.
Okay, so there is Sua Lakshmi asking, is it possible to collect and find AQI data using remote sensing and GIS on particular location? So this is air quality. So air quality data, apart from air quality, one can construct a index. So that index is that index represents the overall air quality. So from some satellites, they provide you pollution data by particulate type or by particular gas type, like say NOx data, CO2 data, methane data. So these are different types of data sets which are available these days. Number one. Number two, CPCB, Central Pollution Control Board, provides the data of their observation stations, right, by a point location wise. So that data can be interpreted or interpolated later after analysis, and one can generate a set of index, is a index out of set of indicators which are available to you. Some of those indicators could be clubbed together. Some of those indicators cannot be clubbed together, but definitely one quality index can be constructed. So there are both possibilities from satellite data as well, and also from interpolating and analyzing the data that is supplied by CPCB, Central Pollution Control.
Thank you, sir. Thank you, sir.
Any other question?
Participants, any question?
So Manojji, if there are no questions, then thank you everyone, and good luck to all of you. And maybe in times to come, we might meet each other on invite of Dr. Manojji when everything comes to the normalcy. Thank you, Manojji.
Thank you very much, sir. Thank you very much for the time, sir. Thank you, sir. To all the participants, our next session will start at 2:30. So we'll try to prepone it. We'll start at, let's say, 2:15, if it's possible. So we'll start at 2:15 so that the validatory section can be started in time, and the feedback and the test can be started right at 5. So thank you everyone. Thank you everyone for attending session 2. We'll be starting the third session at 2:15. So thank you very much.